This is problem number 38 in chapter 4. It reads, suppose you're standing on a train accelerating at 0.20 g's. What minimum coefficient of static friction must exist between your feet and the floor if you're not to slide? I've made a quick sketch of it here showing you standing on the kind of bed of a train car. And let's go ahead and make a free body diagram of you standing on the train car. There are some forces acting. Of course, we have weight directed downward and a normal force directed upwards that's equal to the weight. We'll know that because the sum of the forces has to be equal to 0 since you're not accelerated in that frame, or I should say in that plane. However, this is an interesting scenario. In this case, what's actually pulling you to the right is indirectly the train, but directly it's the frictional force between your feet and the floor of the train car. If that frictional force didn't exist, you would stay exactly where you were. If there was no friction between you and the ground, then you would remain at rest and the train would go ahead and move on and accelerate without you. So there are three forces acting here, and it's that frictional force over here between your feet and the ground that's ultimately producing a net force, which is going to accelerate you hopefully at the requisite 0.20 g's. And so the question is asking, what's this static coefficient of friction between your feet and the floor? We can recognize from our free body diagram here that we can set up some fairly straightforward dynamics equations. In the x direction, we can say that the sum of the forces is not equal to 0, and therefore we can say that the frictional force in this case is equal to our net force. In the y direction, we can say that the sum of the forces is equal to 0, and therefore the normal force minus the weight mg is equal to 0, and ultimately the normal force and the weight are equal in magnitude, but opposite in direction. Recognizing that it's the static coefficient of friction, mu sub s, times that normal force, which produces this frictional force, is equal to ma. You should start recognizing a pattern of substitution here, seeing that the normal force can be substituted with mg. I get mu static mg is equal to ma. The m's cancel out, and the coefficient of static friction is going to be a over g. Further, we can see that this acceleration of 0.2 g's can be substituted here, and so now I'll get 0.20 g's over g. If you wanted to, you could replace that, but here we see it's so easy just to eliminate those g's, and I'm left with my minimum coefficient of static friction being 0.20. Box that in and call it a day.